Hello, my friends. Welcome to the greatest common factor to the shortcut. So here we're going to talk about this shortcut I mentioned in the previous video. If you haven't seen it and you don't know what greatest common factors are, I suggest you go and see it. It's on my website. Otherwise, here we go. So I mentioned earlier that we had a shortcut to writing out all the common factors and then trying to find the biggest one. And there is one. It just involves prime factorization, so if you don't know what prime factorization is, you should probably go see that video too. Probably, most likely. Anyway, so let's take two numbers. Let's choose maybe 12 and 6. Let's say we want to find the greatest common factor between 12 and 6. Now, we probably both know this. We do. But let's use this as an example to introducing our new method. So, we want to write these numbers in their prime factorization. So 12, for example, can be written as 2 squared times 3. Or 2 times 2 times 3. Basically, we're writing it as prime factors. These numbers here are all prime, which means they can't be divided anymore. You can't find a factor of 2 except 1 and 2. And for 6 would be just 2 times 3. And 2 and 3 are both prime as well. So what we want to do now is find this greatest common factor, but how would we do this from this prime factorization thing? Now the way we do this is by saying, okay, so if we have a greatest common factor, it means that there's a factor that is common to both and we want to find the biggest one. Now the way we can make the biggest factor is by taking as many of these little numbers here as possible. Now we know that 2 is common to both, but here we have 2 squared and here we have just 2. And we can only take just 2 because this one is not a factor of 4. And if we take 2 squared, it means our number would be a factor of 4. And then we take 3, and this is just 3 to the power of 1. It's the same thing. And we want to choose 3. And then we know that 2 times 3 is 6. Here, so I'll just write it in red. 2 times 3 is 6. So therefore, 6 is equal to the greatest common factor. Now, how do we do this? Basically, if we write out every one of those prime factorization, and we do, for example, 2 squared times 3 and 2 times 3, we want to choose the lowest one that both have. And between 2 squared and 2, the lowest one, the smallest one is 2. And between 3 to the power of 1 and 3, well, the lowest one is just 3. So if we take those and then we multiply them together, we find the greatest common factor. Now, I told you this is helpful for big numbers, so let's use it for big numbers. For example, let's say we want to find the greatest common factor between, let's choose 504 and 60. Now, the factors of prime factorization of 504 is 2 cubed times 3 squared times 7. And the prime factorization of 60 is 2 squared times 3 times 5. Now, I suggest you pause the video and try this on your own, and then we compare our answers. Okay, so we said we choose the smallest one of each of those numbers. So, we have 2 cubed and 2 squared. 2 squared is the smallest. 3 squared and 3 is the smallest. 7 and no 7, that will be this no 7 here that we're going to just randomly imagine. And then 5 and no 5, and that would be this no 5 here we're going to randomly imagine. So therefore, our greatest common factor is going to be equal to 2 squared times 3, which is equal to 4 times 3, which is 12. Alright, so let's try one more example. Okay, so let's choose the greatest common factor between 350 and 105. We like big numbers. So, prime factorization of 350 is 5 squared times 7 times 2. And the prime factorization of 105 is 5 times 7 times 3. So, we choose the smallest one of each one. Between 5 squared and 5, choose 5. Between 7 and 7, we just choose 7. Between 2 and no 2, we choose nothing. And between 3 and no 3, we choose nothing. if we multiply those out, the greatest common factor is going to be equal to 5 times 7, which is 35. See? We just solved 2 examples together. See how easy that is? See you next time.